Hello everyone. Today, me and my teammate, we will explain our presentation. So the title is The Thermochemical Hazard, the Role of Energetic in Fire and Explosion. So it is presented by Group 7. It consists of Irina, Akif, Aizat and Mirza. For the structure, there will be a 5 key point. First, it will be introduction, then chemistry concept, industrial application, wash concern, and lastly, conclusion. So, I will explain about the introduction. For your information, throughout history, the mastery of energy and chemical reaction has propelled human progress, but it has also introduced devastating risks. In industry like petrochemical refining, chemical manufacturing, and metal processing, the manipulation of energy reaction is both an incredible tool and a constant threat. In this presentation, we will uncover the science behind thermochemical hazard, examine catastrophic example, and link our understanding back to the evolution of atomic theory. Only through deep scientific insight and relentless safety vigilance can we command this force without being consumed by them.
Next, chemistry concepts. Chemical reactions can be dangerous if not handled carefully. Some reactions, like exothermic ones, release heat. If too much heat builds up, the reaction can get out of control. This is called thermal runaway. Reactions with low activation energy can happen very fast, which increases the risk of explosions. Scientists use tools like calorimetry to measure heat, and specific heat capacity tells us how quickly something heats up. In closed spaces where heat and gas can't escape, pressure can build up and cause explosions, especially with unstable chemicals like peroxide. Alright, let's move on to the next part, which is industrial applications of energetics. These ideas are very important in industries. In the petrochemical industry, making fuels involve high heat, and leaks can cause fires. In chemical factories, making things like nitric acid produce a lot of heat, which can be dangerous if cooling systems fail. In mining, explosives like NFO are used, but they must be stored safely or they can explode, like in the Beirut accident. In metalwork, thermite is used for welding and gets very hot, which can cause burns or fires. To stay safe, workers need to control heat and pressure, wear safety gear, follow rules, and store chemicals properly.
Let's look at the main occupational health and safety concept in chemical and industrial process. First, fire and burn hazard. These include burn from hot surface, molten metal, or open flame. Flash fire can also happen when vapor emits quickly, and jet fire may result from high pressure gas. Number 2, explosion. Explosion can cause serious injury or death due to blast pressure, flying debris, and even structural collapse. They may also lead to environmental contamination. 3. Toxic byproduct. Some chemical reactions release toxic gas like carbon monoxide, which can cause suffocation. Other byproducts like NOx and SOx, ignited the lead and VOCs, may be flammable or even cancer-causing. 4. Runaway reaction. These are under control chemical reactions that generate too much heat. If the heat is not removed fast enough, it can lead to thermal runaway or even explosion. 5. Storage hazard. Some chemicals need special storage. For example, sodium must be kept under oil. Other can ignite or react dangerously if stored with incompatible material.
To wrap up our exploration of atomic theory and industrial energetics, let us reflect on the central theme: power. This is a story of power to build, power to destroy, and ultimately power to transform the world around us. From the earliest idea of atoms as indivisible building blocks to the complexities of modern quantum models, our scientific understanding has evolved tremendously. But with that progress comes risk. The unleashing of energy without proper control can lead to catastrophic outcomes. We have seen this in history through explosions, accidents, and large-scale disasters. These moments serve as stark reminders. Knowledge must be paired with caution. As we continue advancing science and pushing industrial limits, we must not only drive innovation, but also carry a deep and unwavering respect for the forces we are learning to harness. This balance between ambition and responsibility is what will define our future success. Thank you.